be talking about collaboration and maybe with a slight focus on how we work within collaboration between different actors within construction. To start off, just quickly introduce my lab. I've been running the Lab for Creative Computation Circle at EPFL. We're a pretty young lab. We started about a year ago, so we're getting there. It's building up on the work that I've formerly done at Princeton at the Create Lab. And we're a lab of people with different backgrounds, architects, engineers. We really work from different perspectives, and I think that is what making this type of work possible. Yeah, what do we actually do? So I wouldn't be here if we didn't work on digital tools, more specific robots. I wouldn't be in this session if we didn't work with robots. But we're really interested in rethinking the way that we work with the robots. So the with here is on purpose. We want to address issues of application, of acceptance of robotic technology, and of accessibility through our work. So I'll go into robotic construction. We've seen a lot of talk about our current issues. Talk about any environmental or social issues that you can come up with. Construction is probably really far up there, making them worse. If you find one where construction isn't in there, I'd be really excited to hear about it. But we know we're in a real time of crisis. And robots and automation, they kind of had this long-time promise that they're going to bring the solutions for at least a bunch of these problems, either through increasing the efficiency of how we use materials or through decreasing the human involvement in manufacturing, making processes safer, et cetera, et cetera. We've seen this in construction, from robots automating bricklaying processes ever since the 60s, up until today, where we are witnessing a race for the fastest automated construction in building right now. So it's a nice vision. We've seen some great potentials of robotic technology that's coming up. But I would point out that there are still quite a bunch of issues that construction is facing. I don't know if this automation, this promised automation of construction is really here. If we're thinking about starting from the 60s, it's been over 50 years that this has been a promise, so we're kind of either eagerly awaiting on it, not to say it's not going to happen. I'm excited to see it happen. But also to be aware of the problems, like why has it been so slow? Why is it, also is this really the right goal to aim for? So there's problems about the scale, about the messiness of the environments. There's definitely questions about where are the humans in that loop. And there's big questions around adoption and accessibility. The technology is still not easy to access. It's expensive. It requires a very high level of skill. And the workers, the people that work directly with it, they're not very eager to take it on. And maybe one slightly underrated issue is the way that this affects design workflows. So from an architect's perspective, as myself, this automation processes, they turn the design process into a very streamlined process, very cut off. You need to design. You need to make it designed for the machine in particular. You need to have it ready to work. Then the design's over. We need to implement it. We need to make it robust to make sure nothing goes wrong, and then you execute it. So you lose a little bit this trial and error, this freedom of adaptability, and being able to react to changes, react to what's going on and what you see there. So what I'm trying to do with my work is really to look for other means of working with the machines, shift away from automation, actually, towards collaboration. And to move towards these more open processes of design that invite change, they invite interaction, and maybe most importantly, invite reflection over what we do. So we do this by focusing on multi-agent processes. I did not start with humans and robots from day one. I actually worked a lot on multi-robotic processes. But thinking similarly, can we make the processes more agile by allowing machines to change tasks, to take on different roles, and to help each other, to support each other? So a robot here can act as a support, or it can act as a placing agent, and they can take turns to adjust their role in the construction processes. We've adapted this method to apply to different material systems. So we moved from very lightweight structures, which are kind of maybe not the biggest proof that the system really works for structurally performant things. So we moved towards heavyweight construction with bricks. We built a vault in London in 2020 with the same principle where the robots can alternate. They kind of change roles of placement and support, and this way they're able to build this arch collaboratively without requiring any support structure. And they can also, they change their role during the construction process. So they will start with this collaborative action where they built the arch as a basic structure, and then they shift towards placing individual bricks, also towards offering support where it is needed. So there's an interplay of what task and what role do I take on right now. There are humans in the process. I'll talk more about this later. The guy you just saw was not just doing some hand massaging, but he was preparing the glue that goes between these bricks. Issues of material, I won't have time to get into those today too much. But at the end of the day, this is a little bit what the process looked like. So yeah, this is nice and cool and shiny, but where are the humans in the process? You've seen them running around doing stuff. So in both these projects, and in a vast majority of robotic construction projects, we have a classical division of roles. So the human or the robot, it's usually used for the task that requires precision. For example, the precise 3D placement of elements that is tricky for humans to control and to get into place perfectly. And then the human is used or tasked with the maybe more dexterous task. I don't know if the most exciting task or the most efficient task. I'm sure you can do welding more efficiently than I did when I tried to weld these things together. But there's a reason for this, in the first place, because it's a bit easier for a human to perform these tasks. Even if it's doable with robots, we have robots that weld. It's just like, it's an implementation pain, and you just do it by hand quicker. But on the other hand, you can make up for these tolerances and imprecisions and changes in material that are always there in construction. So it's a pretty quick fix and hack to deal with these things. But at the same time, I think there's more potential in working with robots and humans besides this task division. So we're aware that humans need to be in construction, but I think there's a possibility to give them other tasks, to allow them to interact with the machine more, and to lead to more flexible design processes which allow both humans and robots to enter the decision-making process. So a lot of what I'll show now are really recent projects. There are explorations that we're starting right now. And we started with a rather playful investigation in human-robot collaboration. So this was during my time back at Princeton, where instead of having the robots and humans perform separate tasks, we asked them to perform the same one, but with different capabilities. So it's a project by Ayla Han. She's currently a PhD student in Princeton under my supervision. We, both the robot and the human, in this case, they're tasked to place an object. And through the precision of the robot, we can control the constraints that are given to the human in how they address and solve this task of building a structure in equilibrium. And what Ayla was really interested in these processes was, is there creative potential? So can we use the robot to enhance creativity rather than to solve this problem really quickly and efficiently? And she did a bunch of studies. She changed some parameters. Of course, the robot and the human, they had different advantages or disadvantages in the process. But her excitement really came from being able to build these seemingly irregular structures that were underbalanced, that neither she alone would have built, nor the robot if you asked it to do an optimal structure to have there. And she's expanded these collaborative processes to full-scale structures in different materials. So she built this bamboo structure with no pre-planned structure whatsoever, no geometry where she started from, but really changing roles step by step with the robot, scanning in the structure and taking decisions on the spot. And recently, she set up a tensegrity structure in which both the human and the robot movements, they're only defined by the current state of the structure. So again, no predefined blueprint whatsoever. In this case, you have the robot positioning an element based on where the previously positioned element is, so using a camera setup to localize itself quickly. And a human gets tasked to adding some of the elements themselves, which lead to the final position of the module. And that way, you can just build up one by one to complete the structure. At the same time, so we also ask ourselves, why don't we add more? So why don't we just look at adding more human decision power in the process, but also what happens if we give the robot more decision power or the computer more decision power? So can this down the line lead to more adaptability, to more flexible processes that could be easily adjusted to new environments and constraints? So this is a master's work, actually, from a student that I co-advised with Professor Mariam Kamgarpur from EPFL as well, where he used reinforcement learning to decide sequentially at every step where to place a new element to bridge the structure from a starting point to an endpoint. Again, with zero predefined geometry, pre-planned structure to start with. So it wasn't about finding the best sequence, it wasn't about building the quickest structure, but really give the material to the machine and see what it does. It's, of course, we're in 2D, where we're working with existing, very limited set of geometries. It has a lot of limitations, but we're excited about the possibility to use the data that we have and the capacity of machines and of algorithms to be able to find solutions quickly and without necessarily the human pre-planning that is required in usual processes. We did a quick test to be sure it's kind of standing, and yeah, it was. You'll just believe me because I'm running out of time. So the last point I want to make is it's great to develop all these new methods. It's really, really fun to work with the machines, but at the end of the day, if we don't change the applications that we develop them from, we won't see an impact. So if we keep building nicely shaped new pavilions and structures with cool geometries, that might have a very limited impact on construction. So we have a few projects that aim at a better use of resources, working with existing and available and abundant material. Zero Waste is a project I did at Princeton University as well, together with my colleague, Professor Erin Bessler, where we asked ourselves if we can use digital technologies for the disassembly and the reconfiguration of structures. So we looked specifically at American wood frame construction and using robots and humans to not disassemble, then inventory the stack of materials, and then reconstruct something, but to do a reconfiguration of the structure in one go without needing these intermediate steps. And we experimented with different reconfiguration, either addressing local small changes, say in the facade level, or facade, but like on a planar level without changing the large geometry, or doing more major geometrical changes in the entire structure, geometry, and structure as it comes with. This was the first initial test to see what are we able to do, and you see the humans in there. We're going back a little bit to the task division, but in this case, the robots, they're used as support, they're used as placing agents, but also to just help maneuver an element out of there where the human could point, hey, I want to take this one down, but it's really tricky for us to do. And we are currently looking at other materials, especially being in Switzerland. You've seen this project shown by Corentin this morning, so it's a collaboration with the SXL lab at EPFL, where we're looking into the question of, can digital tools be leveraged for reclaiming concrete, and what does this look like? And for me, a central question here is, what is the role of the robot in this process? We're going beyond the payload of a classical robot, industrial robot that we typically work with. They are large, bulky, they're not very mobile. So it's really starting to be a question of, are we using the right tools, or are robots now, should they be rather large-scale lifting equipment that we can augment with sensors and other information, and what does human-robot collaboration look like at this scale? and at this level of precision. In particular, can we use the human intuition and capacity to quickly adapt, to identify elements, and to adjust things, specifically for working with reclaimed materials that come with this huge uncertainty. This timer is getting to me, so I'll just quickly conclude. What are we using human-robot collaboration for? Of course, the classical use, efficiency, streamlining. I'm wondering what happens when it runs out. Sorry. So there's always an argument for efficiency and streamlining. That is what I am personally less interested in. I'm particularly interested in the creativity, expanding the design process that we do, enabling new applications that we've seen and we're hoping to push forwards, and through this, making the connection between the human and the machine to increase access and acceptance, to end up with a nice, happy environment where everyone enjoys working with the machines. I will stop. These are the credits of the projects I've shown and some of our publications if you're interested to see more. Thank you.